In stats, we made some more progress with experimental design. We started with this on Wednesday last week, and we made it through a confounding example. We talked about these 4 principles, but very briefly. We'll need them here in a minute. So these 4 things must be present. So you got to be comparing one treatment to another. Sometimes this is comparing a treatment to a control group, or maybe multiple treatments. You got to randomly assign subjects to treatments. You cannot let them decide. Cannot let subjects choose groups. If it's an observational study, it's a natural thing. You're looking at subjects that fall in one category versus another category. But if it's an experiment, they must be randomly assigned. Control, this is not referring to control group. This is referring to extraneous variables, let's say factors, that might have an effect. On the response. I mean, that's typed right above it. As I'm writing it, I see it right there. But these are other factors, like temperature in the room, diet that one should be following while they're taking a medicine, amount of sleep, time of day. These are other factors that you can maybe control. Replication, I feel like this is a poor choice of word. This simply means increase the sample size. It does not mean make people do things more than one time. It does mean let's increase the sample size so we have more units to compare, to look at. All right? So let's practice on the next page how to randomly assign treatments. Oh, and by the way, for our terms, I completely forgot to type single blind. And this is when the subject does not know which treatment they are receiving. And that's what we tried to do in our chips and salsa experiment. So the subject didn't know which salsa they were getting. Double blind would mean the person administering, the person handing the treatment also doesn't know. And then that would mean you would need a third party that prepares things so you can actually use the results. I think everything else is self-explanatory here. Let's dive into conserving energy. So maybe hit pause and skim through this example. We have 2 treatments, and I'm going to clarify what they are right here so that we can refer to them. So treatment 1 is right here. Digital display showing electricity use. And then we have a second treatment right here. And we want to compare the two treatments. So the company has 60 people and 60 single-family residences, and we want to compare the two. Ideally, we want 30 residences assigned to each treatment. So we need to describe how to do that. All right. So what you do is number residences 1 to 60. Create your frame that you're assigning to. So earlier at the beginning of the chapter, we were talking about how to get a random sample, and you create a sampling frame. Now we create a frame of numbers so that we can assign treatments. So we already have our sample. Number residences 1 to 60. And let's use an RNG, random number generator, to generate. There are a couple ways to explain this properly. You could do the alternating method. I like to generate 30 and assign them to one of the treatments, and then let the remaining numbers go to the other treatment. So that's typically how I do it. If you do the alternate way, that is A-okay. But use an RNG to generate 30 unique numbers without replacement. The 30 residences that correspond to these 30 numbers will receive treatment 1. The remaining 30 will receive treatment 2. Now, one thing to point out, I am only allowed to say treatment 1 and treatment 2 because I defined them up here. So since I defined my two treatments, I can just refer to them as treatment 1 and 2. You can call them A and B if you want, as long as you define them. We are going to look at the results, or let the households do this for a month. So it'd be good to wrap it up with that thought. Collect data after a month. And compare results. We'll look at hypothesis testing and what tests you could run, but we don't know that yet, so you just stop with that. Hope that made sense. Next, we're going to look at more terminology, blocks, randomized block design, and we'll practice that with this rat problem. We'll do that on Tuesday. Bye.